Good day, everyone, and welcome to another episode of trigonometry questions. So today we're going to be taking another trigonometry question, and the question states that prove that 1 minus sine 2 theta divided by 1 plus sine 2 theta equals tan squared 45 minus theta. So how do we approach a question like this? So what we're going to do first is probably write our solution. The next thing we're going to do is I'm going to write out, I'm going to recall that according to my knowledge of trig, that sine 2 theta has the value of 2 sine theta cos theta, right? So from the question here, I'm going to replace sine 2 theta here with 2 sine theta cos theta. So I'm going to have something of this nature, 1 minus 2 sine theta cos theta divided by 1 plus 2 sine theta cos theta. Right, so I've replaced sine 2 theta now with these two values. Now, the next thing we're going to do now, in order to simplify the expression we have, or to obtain what we have on the right hand side, we can divide the numerator and the denominator by cos squared theta, right? So the reason why we're doing this is just to just further simplify what we have here. So I'm going to have something of this nature. Top will be divided by cos squared theta. The bottom also will be divided by cos squared theta. So I'm going to have something of this nature. 1 over cos squared theta minus 2 sine theta cos theta, also divided by cos squared theta. So all the terms, then I have over 1 over cos squared theta plus 2 sine theta cos theta divided by cos squared theta. So in this case now, the cos theta here will cancel one of the cos squared theta, cos theta at the bottom. The cos theta also cancel with cos theta at the bottom. And at the end of the day, we're going to be having, remember from our knowledge of trig, that 1 over cos theta is sec theta. That's secant theta. So it means that 1 over cos squared theta will give me a sec squared theta minus 2. Now what I have here is sine theta over cos theta, because the cos theta remaining down here. So sine theta over cos theta is actually tan theta. So I have a tan theta and divided by, same thing happens with the one under, I have a sec squared theta plus 2 tan theta, right? So the next thing I'm going to do now is to further introduce a known trigonometrical ratio, right? So I'm going to have something of this nature, or a known trigonometrical identity, right? Sorry about the ratio, identity. So that I know from our trigonometrical identity that sec squared theta is equal to 1 plus tan squared theta. So from this expression, I'm going to replace what I have here for sec squared theta to be 1 minus tan squared theta. So I'm going to have something of this nature. 1 plus tan squared theta, then minus 2 tan theta will divide 1 plus tan squared theta plus 2 tan theta. So what I'm going to do now is I'm going to rearrange what I have at the top and the bottom. I have tan squared theta starting first, minus 2 tan theta plus 1, and divided by, the same thing goes at the bottom, tan squared theta plus 2 tan theta plus 1. Now, what I'm going to do now for further simplification, I can see from the top here that if I were to factorize tan square theta minus 2 tan theta plus 1, right, I'm going to get something of this nature. I'm going to get tan theta minus 1 all squared, right, and divided by the same thing with the bottom. If I factorize that, I'm going to get tan theta plus 1 squared. So what you can do in this, if you pause the video and check, you can expand this and see if it will lead you to this. You could also expand this and see if it will lead you to this. But I guarantee you that's exactly what you're going to get, right? Now, but because we are heading to somewhere that has to do with tan square theta into bracket 45 minus theta, right? So I'm going to do a little bit of a change in what I have here at the numerator. Now, when I have tan theta minus 1 all squared, I can actually transform it to be the same as 1 minus tan theta all squared over, then here becomes 1 plus tan theta all squared. Now, what you have here, 1 minus tan theta, and what you have here, tan theta minus 1, are actually the same thing. When you expand them, they give you the same value as what you have at the top here. So really, I've not really changed anything, right? So it's just because I'm heading to this particular value, that's why I had a simplification like this. Now, what do I do? Now, I'm not seeing anything like 45 coming in. So the question is, how do I solve something of this nature? Now, I'm going to recall from my knowledge of trigonometry that tan 45 has the same value as 1. So what I'm going to do in essence now is that I'm going to replace this one, the one I can see here and the one I can see here with tan 45. So I'm going to have something of this nature. Tan 45 minus tan theta all squared for the top divided by tan 45 plus tan theta all squared. I've not changed anything because the tan 45 and the tan 45 here are also 1 and 1. So I've not done any change. Now, once I've done this, the next thing I'm going to do is I'm going to recall a particular important theorem or a particular addition formulae for tan. That I know that tan A minus B equals tan A minus tan B divided by 1 plus tan A tan B. So that's what the identity tan A minus B is saying. So I can actually say that from what I have in this expression, right, you would see that I can adjust what I have a little bit to get something of this nature. Watch what I'm going to do to this expression. Now I'm talking about this expression here. I'm going to adjust it to suit what I have here. Now how do I adjust this to suit what I have here? Remember that at this point here, I have a tan theta. But I know that the coefficient of this tan theta here is 1, right? And we already established the fact that tan 45 is 1. So logically, I can transform this expression to be something like this nature. I'm going to have a tan 45 minus tan theta all squared over, I'm going to have a tan 45 plus another tan 45, then tan theta all squared, right? So with this expression I have now, I've not really changed anything because tan 45 here is actually the same thing as the one I have here as the coefficient of tan theta. So literally, I'm actually saying the same thing, right? So with what I have here, you can see that this expression is looking similar to what I have here. But with a little tweak, I'm going to do something. Now, according to my knowledge of indices, right, I can transform this expression to look something of this nature. A big bracket tan 45 minus tan theta divided by tan 45 plus tan 45 tan theta all squared, right? So because the squared here that I have here can affect what I have at the top and at the bottom, which will give me back what I have here. So according to my knowledge of indices, you can check that rule. The rule actually says that if I have a over b all to the power of x, the same thing as a to the power of x divided by b to the power of x. So like from here now, I'm going back to what I have here. So it's the same thing. So what I have here now, remember that what I have here inside of this bracket looks like something here, right? You can see tan A, which is like tan 45, tan B, which is like tan theta 1, which is same thing as tan 45, if you know what I'm talking about. Then tan A2, tan 45, tan B, and tan theta. So literally, I can take back what I have here back into what I have here. So I'm going to take back all of this inside of this bracket. I'm going to take it back to mean tan 45 minus theta. Then I have the squared. Right. So literally what I have here now indicates that here, which is the addition formula for tan, has actually been used to transform this to what I have here. My A being 45, as you can see, and my B being theta. So A minus B here that I have here becomes 45 minus theta, right? And at the end of the day, if I square what I have here, automatically it transforms to be tan squared 45 minus theta. And that's what I will have as the final answer. So you can see the step-by-step approach to how I was able to obtain 1 minus sine 2 theta divided by 1 plus sine 2 theta equals tan squared 45 minus theta. Yes, there might be some manipulation I've done. That's why you have to go through it again and go over it again and see if you can actually attempt it yourself. Pause the video, you attempt, you see if you can try it all over and over again. So this is where I'm going to stop right now. And if you have any issues or any problem, you can just comment or make your comment in the comment section below. And if you have any mathematical concept you want us to help you with, we're always ready to deliver the best to you. Have a wonderful time going through the question. Thank you.